In this video, we're gonna focus on domain and range of a relation. So we are given a question here. They said, given the relation R equal to set of 3, 1, set of minus 5, 2, set of 1, 5, set of minus 3, 2, set of 9, 14. We are asked to obtain the domain, that is the domain and range of this particular relation. So before we solve this question here, class, solution first. Before we solve this question here, let's know what domain of a relation is. And again, let's know what range of a relation is. So let's take the mathematical definition of domain of a relation. Please write. Domain of a relation is the collection of all the first entries. Domain of a relation is a collection of all the first entries. Most times, we might not be asked to find domain of a relation. It might not be expressed as domain of a relation. So we have other ways of expressing domain of a relation. So whenever you are asked to find the dome of R, this expression simply means domain of relation. Please take note. Whenever you are asked to find the dome of R, is the same as domain of a relation. Okay. Now let's take the next note here. Please write range of a relation. Range of a relation is a collection of all the second entries. Range of a relation is a collection of all the second entries. Now we can represent the range of a relation as range R. Please take note. So we can denote the range of a relation to be range R. So whenever you're asked to find the range R, it means range of a relation. Please take note. So let's solve the question here. We are given a question here, class. They said, given the relation R equal to, this is the relation given to us here, class. This. Okay, let's write it down here. The relation given to us here is relation R is equal to the set of 3, 1, minus 5, 2, 1, 5, minus 3, 2, 19, 14. And we're asked to find the range, the domain of this relation, okay? So this domain of this relation, remember domain is a collection of the first entries, that is the first member in this relation. So when you collect the first members in this relation, we have this to be set of 3 minus 5, 1 minus 3, 9. Now the next is range. The range The next is range. The range of this relation R is equal to class. Now range is a collection of all the second members. That is 1. We have 2. We have 1 again. But remember, this is a set. This is a set because the bracket here is telling us that it's a set. This is a curly bracket. So in a set, we don't repeat members. So we have collected 1, collected 2. So we have the next set, that is the second entries here, is 5. The second one here is 2. I don't need to take the 2 again because we have already collected 2. The last one here is 14. Please take note. So this is the range of this relation here. Okay. So let's solve some advanced questions here under domain and range of a relation. Okay. Okay, let's solve this question here, class. This question 2. Before we solve the question here, let's understand the question perfectly. They said, given set D equal to 16, 25, 36, and set of E equal to 1, 2, 3, 4, 5, 6. Okay, they said, let arrow be the relation from D to E, where D relates E, if only if D is a perfect square of E. Find domain of R. Okay, now we are asked to find the domain of R. So let's understand what domain is first before we find the domain of R. Please take note, okay? Solution first. Okay, now class, the domain of R is the first entries in a relation. Please take note. Before we find the domain, the first entries in a relation, that means we have to know what relation is. We are given two sets, set D to be 16, 25, 36. We are given set E as 1, 2, 3, 4, 5, 6. And we are asked to find D relate E. This expression here, D relate E, is the same as, please take note, is the same as D cross E. So when we are relating two sets, it's the same as the Cartesian product of both sets. Please take note. If we relate two sets, D cross, same as the Cartesian product of the both sets, that is D cross E. So now let's find D cross E here. We have to replace this set. The set D is 16, 25, 36. Cross the set E is 1, 2, 3, 4, 5, 6. All right, now to relate both sets, that is set D and set E, we relate this in a pair, that is in an ordered pair. Please take note, that is 16 times 1 will give us 16, 1. 16 times 2 give us 16, 2. So we multiply this in an ordered pair. Please take notes, okay? But at this point here, they gave us a condition. That means this particular relation is a conditional relation, okay? So they gave us a condition that for us to relate D and E, we only relate that when D is a perfect square of E. So if I want to relate this first element here or member here, 16, I will only relate 16 with its perfect number. And the perfect number of 16 is 4. Please take note. That means 16 will relate with 4. I will have this to be 16, 4. So let's move into the next number. There's no other perfect number here that's of 16, okay? Now let's move into the next number, that is 25. 25 will relate its perfect number, which is 5. So when you do that, we have something like this, 25, 5. All right, there's no other perfect number here for 25. Now move to 36. 36 will relate its perfect number here. So 36 multiplied by 16. Representing this in an order pair, this will be 36, 6. Please take note. So this is my relation, okay? The multiplication of two sets in a Cartesian product is said to be relation. Please take note. So this is my relation. Class, we are not asked to find the relation of this set. We are asked to find the domain of the relation. But for us to find the domain of a relation, we have to know the relation, or the relation have to be given to us, okay? Now, this is the relation here. Now, to find the domain of this relation here, we know that the domain of a relation is the first entries, the first collection of the first entries here. That is the first element in a relation. These are the first elements here, 16, 25, 36. So the domain of this relation here will be equal to class 16, 25, 36. Please take note. So this is my answer. All you have to do to get the full video here is to hit the subscribe button. Okay, thank you.